Exploring the Oracle Database Architecture. The content of this nugget is important for us because it's foundational to our understanding of the Oracle database. We're going to begin with some relevant terminology, the basic nomenclature or the basic vocabulary, things that every Oracle DBA needs to understand. What is an instance and what components comprise an instance? What is a database? What components comprise a database? How do the instance and database relate to each other? And so forth. We'll then spend the rest of our time in this nugget looking at the three chief structures that make up an Oracle instance. We have memory structures to examine, process structures, and storage structures. By the end of this nugget, you'll have a really good grasp of the basic foundations of the Oracle database architecture. Let's get started. The suggested reference that I have for you in this nugget is a fantastic book from Oracle Press called Oracle Database Administration for Microsoft SQL Server DBAs. I've read this book from cover to cover, and the reason why I suggest it for you is because I know that many, I'm not going to say most, but many CBT Nuggets customers either have expertise with Microsoft technologies or are building expertise with those technologies. So for those of you who have invested blood, sweat, and tears in learning the Microsoft SQL Server database platform, you'll want to leverage those skills and draw analogies between what you already know in SQL Server and what you don't yet know in Oracle Database. To that end, this is a fantastic text, and the author, Michelle Melcher, does a great job of explaining everything. The website of the moment that I would like to suggest to you is the Oracle 11g Documentation Library. I would just go to Google, Bing, or your favorite search engine and do a search for Oracle 11g Document Library, and you'll want to map to the appropriate release of the product. As of this recording in April 2011, we're up to release 2, and there is a separate version of the documentation library for each version. The screenshot you see here actually is focusing on Oracle Database 11g Release 1. For your exam success, I would always recommend you stay with the very latest release, because releases of Oracle Database, while they don't change the licensing schema of that version, they do almost always give you new and improved features. The documentation library is fantastic because, number one, I find the search facility to be very accurate and very nice. You can do a search across all books or just within a specific title, and then we have direct links either to the online HTML representation or PDF download links to the most popular documents. And I've found more recently that once you open one of these documents, you can actually download it as the EPUB format. Now, EPUB is pretty much an industry standard ebook format. So, for instance, if you're using the Apple iPad, the iBooks application in iPad reads EPUB. So you can take the documentation library books and bring them into your mobile device for reading, offline reading, and it's a very nice way to go. So please bookmark this site. Database basics. I'm going to be giving you both general descriptions of these terms as well as Oracle specific tightenings of those definitions. Now, what do I mean? Well, let's start right at the beginning. A database, formally defined, is a system intended to organize, store, and retrieve data. Simple as that. Doesn't get any more basic than that as far as a definition. Now, as far as Oracle is concerned, in Oracle's definition of a database is a set of files on disk, and you'll understand exactly what files comprise an Oracle database momentarily. So think of it as the broad definition that pertains to any database system, from something as lowly as SQLite or Microsoft Access all the way up to SQL Server, Oracle DB2. A system to organize, store, and retrieve data, and that's important. Organization deals with database design and normalization. Storage deals with referential integrity, table relationships, constraints on columns, and then retrieval, of course, deals with your SQL statements like select, reporting, etc. Nowadays, we have relational databases being the norm. Traditionally, in the past, we've referred to databases as either being a flat file or using the relational system. A flat file database generally is just a single table. Think of a Microsoft Excel worksheet that consists of columns that describe data and rows. Each row is a discrete entity in that flat file database. The problem with flat file is that there's no relationship among various, in Excel, let's say, worksheet tabs. So you wind up over time with human error bringing to the forefront, duplication of data, storing the same data in multiple locations, problems with referential integrity. Actually, there is no referential integrity in a flat file system because there's no relationship among those tables, but you certainly have data integrity issues. Therefore, relational databases are the way most people think. Now, there are folks who want to go back to a non-relational system. There are folks who do not believe in the structured query language as a way to manipulate and access relational database information, but we're going to stay mainstream in this training because, of course, Oracle is the quintessential example of a relational database. Generically defined, a relational database is a database that consists of two or more linked tables, and a linked table is simply a shared column in between two tables, meant to enforce integrity between those related tables, but chiefly intended to eliminate data redundancy. Instead of keeping, for instance, all employee information in a single table, where you have employee ID, first name, last name, and then let's say we have a column in our employee table called department that tracks their department. Now, you're going to have a lot of redundancy in that column because you may have 25 people in the marketing department, 10 people in accounting, another 18 in IT. In order to use data normalization, this means breaking out data as discreetly as possible, such that an easy fix to this would be to create a separate table altogether for departments that consists of just two columns. You have some unique identifier that denotes each department, and then you have the department name. How do we create a link or a relation between the tables? All we have to do is create a matching column in the employees table that references the unique ID column in the department table. That's called a one-to-many relationship because, for instance, marketing is going to show up how many times in the departments table? Just once, right? By contrast, as I said, you may have close to 20 employees who are tracked in the employees table who are from that department. It's a one-to-many relationship. And what's nice about creating that link is that you have integrity, such that if we try to add a new employee to the employees table and reference a department ID that doesn't exist in the base table, then Oracle or any relational database management system worth its salt is going to generate an error and prevent you from inserting that row, you see? So we get much better data consistency and elimination of redundancy in a relational database. Now, Oracle is officially called an object relational database because it takes all of the relational database principles and applies them to the object-oriented programming or OOP model. Now, we don't have the time and it's beyond our scope to go into object-oriented programming, but OOP is like the latest, although it's been around for a long time, it's still considered the standard way to develop software. Object-oriented programming languages like Oracle's own Java have at their core some of the same goals as a relational database. You want object reuse, you want object consistency, and you want to eliminate duplicate work and duplicate data. You have objects which are discrete instantiations of classes. Classes in object-oriented terminology are essentially blueprints for different objects. You put your rules in your class, and then each time you instantiate an object of that class, it's initially created just like a cookie cutter, exactly like the template. That's called inheritance. And there's a whole lot of other neat vocabulary that goes along with object-oriented programming. Just know that we have all of those principles and mechanisms and design patterns at our disposal in Oracle. Finally, as far as programming languages are concerned, Oracle Database gives us some choice here. Java is a natural choice because Oracle owns Sun Microsystems. So if you really are going to get into Oracle development, it's pretty imperative that you learn the Java programming language. But for us DBAs, it's imperative that we learn the structured query language, which is our standard data access language, and then PL/SQL. This is Oracle's own procedural SQL. It allows you to apply programming logic to SQL. SQL on its own is just concerned with data retrieval, data creation, data update. PL/SQL allows you to take your code and put it on another level as far as intelligence is concerned. Now let's get into the Oracle database memory structures, another vocabulary term that's so crucial that you understand. According to Oracle's own literature, an Oracle instance refers to several memory structures and background processes that support one and only one one database. We could consider an Oracle server to be an instance connected to a database. There's a one-to-one relationship. And I'll say this a lot throughout this training because I know some of you come from MySQL or SQL Server environments where you can pop up new databases as often as you want. It's not like that with Oracle. Every database needs an instance to plug into. And an instance, again, provides the memory. And when you think of memory, think of physical RAM memory as well as virtual memory, where you use hard disk space as swap space. And you have a series of background processes. Each has its own role to play in database operation. Now, it's beyond our scope in this exam, but when you get to the OCP level, you need to learn some things about real application clusters, RAC or rack environments. This is where you have more than one instance. In other words, more than one installation of Oracle 11g, all focused on the same single database. Clustering is a really good idea if you need 24/7 uptime because you can schedule maintenance on any single node. And as long as you have at least one active rack node servicing the database and servicing user connections, the database is still online. Moving on. The next memory structure thing, the chief distinction you need to keep straight for your exam and for your Oracle DBA success, are the differences between the system global area, also called the SGA, and the program global area, or PGA. Now, the SGA it's a partitioned collection of memory. It's a memory structure. So when you bring up an instance and attach it to a database, Oracle allocates a bunch of RAM into, I guess we could call them compartments or substructures. Some of them are required, like the database buffer cache, the log buffer, the shared pool, and some of them are optional, like the large pool, the Java pool, and the streams pool. We're going to concentrate just on the major ones, the required ones in this training. The database buffer is an area of memory that's used as a scratch space for SQL. This is a crucial workspace for Oracle because the database buffer is going to temporarily store recent user queries as well as changes that are made to the underlying data files. You have to remember always that you want to do as much work as possible in memory because the difference in I/O, input-output, the speed difference between memory and hard disk is literally orders of magnitude in difference. So we'll be referring to the database buffer a lot throughout this training. When we get to process structures, we're going to learn that a background process called the database writer performs what is called lazy writes in the background by taking modified data blocks. Like let's say a user were to connect to your database and add a new employee to the employees table. Well, initially those changed blocks will be queued in the database buffer in memory. When a commit occurs, more on that later, the database writer takes that changed information and incorporates it into the data files where they're permanently stored in that database. Another memory area called the log buffer is a staging area for the redo log, and we're going to learn more about the redo log in just a few minutes. The redo log is kind of like a court transcriptionist. If you've ever seen a trial on TV or actually attended a trial as a jury member or as an observer or whatever, you'll note that there's a transcriptionist there that's typing out every word that's spoken during that trial. Similarly, the redo log is the repository, the file that stores all of the SQL statements that modify data in the database. It's a nice blow-by-blow or statement-by-statement record of what's changed. The idea with the redo log is if something happens to a data file or a user session, we can replay the SQL statements that are recorded in the redo log and bring the database back up to speed. So to reduce contention with hard disk, we have a memory area called the log buffer that stores and queues up those SQL statements, and sure enough, there's another background process, this time called log writer, that periodically flushes the log and records those SQL statements to your online redo log files. Third, we have the shared pool. This again, I can't overestimate or overstate the importance of this memory structure. The shared pool stores parsed SQL, PL/SQL code, code, parameters, data dictionary information. So therefore, especially when you hear data dictionary, we'll learn more about that momentarily, you can understand that the shared pool is almost always in use as long as the database is up. When Oracle exerts blood, sweat, and tears, if you don't mind the personification, in satisfying a user's query, it builds that query execution plan and stores it in the shared pool, such that if another user comes along and runs that same SQL statement, the execution plan is already stored in memory, and therefore the user gets a much better response. So those are the required aspects of the system global area. I hope you're thinking along the lines of, wow, that's a lot of memory to configure. How do we appropriately size the SGA so that we have enough room for each of these buffers? And if you're thinking that, congratulations, and I'm about to help you out with that shortly. The other memory structure is called the Program Global Area, or PGA, and by default, when you install Oracle, it's in what's called dedicated server mode, and you have one server process spawned for every user session. So if you have 5 simultaneously connected users, each one of those users has their own server process that runs not on the client but on the Oracle server, and each user has their own memory space, as I just said, also called a Program Global Area. Within the Program Global Area, each user has their own private scratch space for sorting, for running queries, for storing SQL, etc. From the Oracle documentation, I've borrowed a really nice schematic that you see all over the place in the Oracle documentation that shows you pictorially what's happening. You have in the instance on the server the SGA, or the System Global Area, and then inside there you have your required and optional components. An example of an optional component would be a memory pool for Java operations. If you're running Oracle in conjunction with a Java application server, then that's certainly going to be more important to you. Outside of the SGA, on each user's box, they spawn a connection, but it's important that you understand that most of the heavy lifting is occurring on the Oracle server and not on the user's machine. So the PGA and the server process act in a sense as proxies for the connected user. The user is sitting at his or her desk interacting with Oracle through a web application or a desktop application, what have you, and on the server each one of those sessions by default has its own memory space. Now if you're thinking to yourself, Tim, that's probably going to consume a lot of RAM as we start scaling up users, you're absolutely correct. And to that end, Oracle allows us to configure the server in a shared mode where you have a connection pool instead of separate PGAs per user. We'll talk about that too later in the course. To pick up on a question I asked a couple minutes ago, given all of these memory structures, how much do you have to know as far as Oracle best practices for sizing them? We want to be careful not to give too much memory to Oracle, but we certainly also don't want to starve Oracle either, or our performance is going to suffer. The great news is that in contrast to earlier versions of Oracle where you really did have to size these memory structures individually, now that we're in Oracle 11G and in the 21st century, Oracle has automated memory management. You can do it all yourself if you want to, if you're old school, or you can employ AMM, automatic memory management, to control the SGA, PGA, or both. You can actually set a single initialization parameter. It's called memory_target, and that, as far as Oracle is concerned, is the Oracle system-wide usable memory. And once you specify memory target, Oracle says, okay, I'm going to tune memory from here on now. I'm going to reduce or enlarge the SGA and PGA as I need to. Isn't that great? So that's on one end of the spectrum, just doing automatic memory management and specifying memory target. But as I said, you can selectively do AMM for SGA or PGA, or you can do manual shared memory management. It's up to you. Specifically, how do we size the memory? It's pretty easy, actually. You can log into SQL Plus and run an alter system set command, which I'll show you in the demo in just a moment, to change the memory target value, or if you want to do manual memory management, you can do that as well. That's going to modify your server parameter file. Actually, all of these changes will do that, and we'll describe the P file and the SP file in due time, so hang on to your hats. When you create a database using the Database Configuration Assistant, one of the screens allows you to size memory, again, either specifying memory target and letting Oracle take care of sizing memory, or you can do it yourself. Finally, if you're into a graphical approach, we have the Oracle Enterprise Manager console SQL, lots of controls that we can get to that require that we know no SQL. We can examine the memory structures of Oracle Database either through the SQL Plus client or through Enterprise Manager. Remember, we can open up the database control, also known as Enterprise Manager, by opening our Oracle Home Start menu group and hitting Database Control. I've logged in as SYS with the SYS DBA privilege. From the Oracle Enterprise Manager homepage, we'll want to navigate to the Server tab, and then we'll focus on Database Configuration. Specifically, you see Memory Advisors. Let's go into there and just show you what we've got going on. You'll note that on my instance, Automatic Memory Management is enabled. You can just enable or disable AMM with one click from here. Total memory size and maximum memory size give us the memory target value. The difference between total memory and maximum memory is that the memory max target or maximum memory size, remember these are both initialization parameters. Memory max target specifies the maximum value to which a DBA can set the memory target initialization parameter. So they're basically going to be the same. If we scroll down the page, we can see graphs that show us allocation history of memory. Then we can look specifically at the System Global Area or SGA or the PGA. It gives us an allocation history over time. Ours is pretty steady, as you see. And then down at the very bottom, we get metadata pulled from the data dictionary that shows us the partitioning, the current allocation of memory, and how it's spread in the SGA across things like the shared pool and the buffer cache. You'll see that these two, and I think this should make sense to you, have the largest allocation because they're just used all the time, especially that shared pool. Now, if we make changes to the values, you'll note that we can optionally apply changes to the SP file only. We haven't talked about this file to a great degree of depth yet, so I'm going to hold that off. I also want you to see that as you make changes here, you can show the SQL behind those changes. For instance, let me change my total memory size to 800, and then if we click Show SQL, it tells us what SQL statement will be supplied under the hood. Isn't that cool? It tells us alter system set scope equals both. Now, I'm going to explain what this phrase, what this statement means in more detail now because I'll minimize database control and we'll bring up an administrative command prompt. I'm going to log into SQL Plus using my currently logged on Windows credential. That's the /. And because my currently logged on account is a member of the DBA group on this machine, I can log in with the SysDBA privilege, which is going to give me full DBA access to the entire database. Now, to look at some of the memory structures and the automatic memory management stuff through SQL Plus, one thing we could do is run show parameter to access the memory-related initialization parameters. And instead of just show parameter with nothing, which gives us everything, I'm going to search for all parameters containing the keyword memory. And sure enough, we see both memory target and memory max target. If we wanted to change the value of memory target, as you saw back here in database control, we can issue alter system set memory target equal, and why don't we bring it down to 750. If I press enter, you notice that the SQL Plus gives us another line number. You have to remember in Oracle that all of your statements need to be terminated with the default delimiter, which is the semicolon character. So now if I show parameter memory target, it gives us the new value. Now you might be wondering, does that change go into effect immediately? The answer to that is yes, and the proof is what I just showed you here. It tells us the value is 752. I'm going to use my up arrow twice to bring back my Windows buffer history to get back to my alter system set command, and I'm going to reset that to 820 megabytes. Now, the reason why this goes into effect automatically, let me come back to database control, is that when you issue an alter system set command to change an initialization parameter value and you do not specify the scope keyword, then your change will affect both the currently running instance as well as that change will be permanently recorded in the server parameter file, such that if we were to bounce the database, were to shut it down and start it it up again, we would still retain that change. More on that in a future lesson, as I said. To look at current sizing of our SGA, we saw how to do that through the Oracle Enterprise Manager, but we can query our $V dynamic performance views. There's one called $SGA, and that gives us our buffer sizes. We can also query $SGA info to get some more information. Gives us a much more robust list, tells us the current sizing of our caches, and also the res column means, is this resizable or not? Is it dynamically resizable? We can always change these settings in the SP file, but can we dynamically change their values from memory? To get a list of all of our dynamic performance views, we can, and let me clear the screen. A command that you should know in SQL Plus is the host command. If you issue host with no parameters, it takes you what appears to be out of SQL Plus and into your operating system environment. So I can clear the screen, run a current directory list, whatever I want to do, and then when I hit exit, it takes you back out of the host environment and back into SQL Plus. To exit SQL Plus, we can disconnect, which just disconnects our session but keeps us in SQL Plus, or if we hit exit, it actually does disconnect us. Let me get back into SQL Plus. What I will often do if I need to run a quick host OS command is to type host, the command, whatever it is, could be clear in Linux or CLS in Windows, and then you're still in the SQL Plus environment. Anyway, I'm going to run one final query. I'm going to grab the owner and view name columns. Remember, you can press enter as many times as you want here. You'll get line numbers. I'm going to bring that from my DBA views system view, and I'm going to filter rows such that the view name column is like $, or like V, in other words, starts with V. Like is a pattern matching keyword. And for more information on how I construct these queries, you'll have to check out my training for CBT Nuggets on SQL fundamentals. This gives us a lot of information, doesn't it? More than probably could fit in your command buffer. So let me show you another trick. Let's turn on spooling and say we're going to write a spool file to cspool.txt. I'm going to use the list command to bring back my command buffer. In SQL Plus, SQL stores the last single statement that you've created, just one. So in this case, list tells me that we have this query still in our buffer. And if I want to rerun that last query, I can use the / character and press enter. Now it appears that the output just went to standard out. Let me turn off spooling and let me run host type c.spool text. Now that probably wasn't very appealing because we're still in a command prompt environment. Let's just bring it up in Windows Explorer to prove that spooling does in fact take the results of that query and brings it now into a pretty nicely formatted report. A little bit later I'll show you how to customize report output. Oracle background processes are the second part of the Oracle instance. The first, as we just talked about, being the memory structures. In computing, a process is an instance of a computer program that's being executed. That definition comes to us courtesy of wikipedia.org, by the way. Other characteristics of background processes is that they tend to start with the instance. You configure these things to start automatically at instance startup, and generally speaking, the background processes stop with instance shutdown. Think of Windows services as examples of background processes. You can configure those services to start up when Windows starts up and stop when Windows shuts down. For example, Oracle running on Windows keeps all background processes under a single master process called oracle.exe. That actually is one of the relatively few big differences between Oracle database running on NIX versus it running on Windows. Under Linux, your Oracle background processes are individually ID'd. You can see them singly or separately if you run the ps command, and each process is given a process ID. For many reasons, well documented, Oracle decided to tuck the Oracle background processes as threads underneath a single master process. And that makes sense. Nobody wants to keep track of a dozen or so separate processes in Windows unless they absolutely have to. You can interact with those background processes directly from SQL Plus by running the query select program from $process order by program. Now $process is a system view. It's a data dictionary view also called a $V view because the aliases for these built-in views are prefixed with $V. The technical name for these $V views are dynamic performance views because they give you dynamically changing information depending upon the current state of the database and of the instance. Now then, you're probably wondering, what are the major background processes? Here they are. You'll note that they're given short names. You should know these, of course, for your exam, but you'll also find in Oracle literature the major processes are given by their short names. SMON is the system monitor. It's your main housekeeper of the Oracle instance. SMON is the process that's responsible for actually mounting, opening, and closing the database. It also works to do system recovery in the event that recovery is necessary after, say, a dirty shutdown of the instance, and it collates free space and data files. So you can look at system monitor, as I said, as the house mother, the house father, or the housekeeper, rather, of the Oracle database and instance. The process monitor, or PMON, is the major process that's responsible for monitoring server processes. Remember, a server process, also called the PGA in its memory structure form, is a user-by-user process and detects problems. So process monitor is going to periodically query each of those sessions, determine which are idle, maybe a user disconnected abruptly. Process monitor is going to detect that and then decommission the PGA. So it's constantly running in the background on behalf of server processes. We've talked about the database writer and the log writer already. You'll remember that in the memory structure of Oracle, we have the database buffer that stores changed blocks. Maybe an update was made to one table. Maybe a delete is made to another. Maybe an insert is made to a third. Well, those changed data blocks are stored initially in memory, and then periodically, when a commit happens every 3 seconds, there's a few criteria under which the DBW goes into effect and writes those changed blocks permanently to the data files that comprise the database. When the database writer kicks in, it also advances the checkpoint. A checkpoint is a periodic marker that is recorded in the control file, which we haven't yet discussed, but we will shortly, and also the redo log files, and it's used as a way during instance recovery for Oracle to know which transactions have been committed and which ones haven't been committed. Now, you'll note that the database writer process is given as DBWN. You know what DBW stands for. What does the N mean? The N is meant as an algebraic variable. You can actually create more than one database writer if you want parallel processing on your server, and Oracle in their documentation has best practices for the situations in which that's necessary. However, for our exam objectives, we're only going to be concerned with a single database writer. The log writer, as previously discussed, periodically flushes the redo log buffer, aka memory structure, to the redo log file on disk, and the redo log, again to repeat, allows us to do recovery by replaying SQL statements, specifically data manipulation language or DML SQL statements, things like inserts, updates, and deletes, and can bring your database back into a consistent state in that recovery situation. The checkpoint process works in close conjunction with database writer. Remember, I said that the database writer can advance the checkpoint. The checkpoint is a process dedicated specifically to that process of updating the control file and data file headers with that checkpoint information, and then instructs the database writer to write changed blocks to disk. So you can think of the checkpoint as kind of a metronome that periodically draws a line in the sand, again, both in the control file as well as in the data file headers, as far as which batches of transactions have been committed and are 100% complete, such that in the event of a failure, we can redo those transactions and again, bring the database up to a consistent state. It's crucial that you understand, everyone, that the checkpoint process does not write data blocks to data files, nor does it write redo blocks to online redo log files. The checkpoint simply performs the recording of that checkpoint in the control file and the data file. The database writer writes changed blocks to the data files. The log writer writes the in-memory SQL changes permanently to the online redo log files. Let's have a look at process structures in Oracle Database. We'll start with SQL+. I'm going to run a query from $session, one of several dynamic performance views you should be aware of. I'm going to grab the program column from that view. I'm going to order by program. And this is cool because it shows us in Windows, as I said earlier, that you have one master process, oracle.exe, and then the specific process structures run as threads beneath oracle.exe. Now let me open up my services control manager, services.msc in Windows, and I'll show you. It won't give you the thread count here, unfortunately, but if I scroll down to the O's, you'll see we have a service called Oracle Service, and then the name, the service ID of your database, which I used ORCL. And like any other Windows service, you can customize what happens if it fails. You can have it restart automatically. I wouldn't suggest changing the logon for the service unless you're absolutely sure of what you're doing. You can download the sysinternals tool Process Explorer to get a fix on these processes. Let me run one other command. First, I'll do a host CLS. Let's again select program from vProcess, order by program. And it's just, again, another way of looking at your background processes. Windows has an advantage, I think, over Linux in certain respects. We have this Microsoft Management Console, which I'm going to pop in. If you go to add or remove snap-ins, there's an Oracle MMC called Oracle Managed Objects. And if you bring that guy in and expand the tree, expand databases, we can look at the properties of the database. We can look at the process information for that database, and it gives you a specific list, a really nice metadata list that gives you the thread ID, the user under which that thread is running, what type of process it is, background or foreground, and in the event of troubleshooting, you can actually kill threads if you need to. Note also, by right-clicking the database in this MMC console, you can bounce the service and you can specify startup and shutdown options. Very cool. Very handy to have this in Windows. Finally, let me right-click the taskbar and start the Task Manager. You're probably familiar with this tool. I certainly hope you are. On the processes list, you note that we don't see oracle.exe, do we? That's because right now we're showing only those processes that are owned by the currently logged on user. That's Oracle. Let me hit Show Processes for all users. Make sure we're sorting our image name alphabetically. And if we come down, there is our Oracle service. The description is Oracle RDBMS kernel executable. And like I said, Process Explorer is cool because you can hover over this and it will show you the breakdown of the process structures. Oracle storage structures. The three required file types in a database that comprise the storage structures of said database are the control file, the online redo log files, and the data files. Remember that the instance, according to Oracle, refers to the memory structures and background processes that support a database. In Oracle nomenclature, the database itself refers to the physical files that comprise that database. And you'll note the distinction here. This again is a graphic from the Oracle literature between logical storage structures and physical storage structures. The way to keep those straight in your mind, friends, is that logical storage structures are objects that are invisible to the operating system. In other words, they don't show up in Windows Explorer. They don't show up in some file manager regardless of your operating system. By contrast, physical storage structures certainly are visible to the operating system and are therefore subject to constraints of said operating system. In Windows, think of things like NTFS security, shared folder security, all that kind of thing. So I guess the question next is, how do we tease apart the meaning of these logical versus physical structures? Let's start with the easier side where there's just one object, and that is the logical structure called the table space. This causes a lot of confusion among newcomers to Oracle. The table space is a logical container, and again, logical meaning it's invisible to the operating system. It's a container for data files. Now, it's not like a folder in Windows Explorer that contains a file, because that folder is not a logical but a physical structure on disk, right? The table space reference, all of the table space references and metadata are contained in what's called the data dictionary, or the metadata of the Oracle database. We use table spaces to provide organization, management, and performance to our data files, okay? So we can provide attributes in Oracle database to different table spaces. We could say this one here is for archival purposes. We'll set it for read-only. We'll say, well, our data file that contains very heavily queried information, we'll store that disk on a separate drive controller, a separate disk array, really fast one, and we'll store that data file in this table space, and we'll use this table space only for really high output operations, you see? So you can use table spaces for organization, for management, and depending upon the disks that your data files are in turn stored in, you can get increased performance out of them as well. We'll be working obviously a lot with table spaces as we go on. Now, while a table space can contain more than one data file, each data file can belong to only one table space. Make sure you understand that. I've already crossed the road, you can see, between the logical construct called the table space and the physical structure known as the data file. The data file is a file that typically has the extension DBF, very close to MDF that's used in SQL Server, right? This is a binary file. You're never going to be able to read it with a text editor that stores row data. Simple as that. Table and row and object data in the database. The control file is a very small binary file that records the physical structure of the database. It includes your core metadata that the database needs and the instance needs to bring the database online. What is the name of the database? What are the names and locations of your data files? What are the names and locations of your online redo log files? What is your current LSN? That's log sequence number. Each transaction that gets recorded to the database is affixed with a log sequence number. It's a way to increment the database and enables Oracle to tell at startup whether it's in sync or out of sync. If there's a discrepancy between the log sequence number that's in the control file versus what's in the redo logs and data files, then Oracle understands it has to do some instant recovery. As you already know, checkpoint information is recorded in the control file. Consequently, even though the control file is a tiny little binary file, you cannot start the instance, and you certainly can't raise the database without a valid control file. The final, we've already talked about online redo logs. The final physical structure that we're going to talk about now is the server parameter file. We're going to do a whole nugget on this shortly, but right now I will say that this is the equivalent of the registry for Oracle. The server parameter file contains all your initialization parameters. It defines things like memory, work areas, remember automatic memory management and max target and all that good stuff? It defines the operational characteristics of the database. So similarly to the control file, it's crucial that you have a working server parameter file. Just to drive this point home because it's so important, let's summarize those physical structures again, starting at the bottom. The data files consist of data blocks. There's some terminology that we're going to need to cover with regard to how data blocks come about. You'll definitely be asked questions about that on your exam, on your Oracle exam. Online redo log files store every change applied to the database, not the changed data blocks, not the data itself, but the SQL that defines that data. Let's say we did an insert statement to add a new employee named Joe Smith to the database. Well, the actual data that's in that table upon insert is not what's stored in the online redo log file. By contrast, the actual insert statement that was used to put that new record in that database is what's stored. And there's two types of online redo logs. There's online and archive. We're going to talk more about that later. You'll notice that next to control file and online redo log files, I put TIP, multiplex. Multiplex means to store multiple copies of that file on different disks for fault tolerance purposes. It's not for performance management and parallel processing. It's simply to avoid the problem if one of your control files gets hosed up, you'll be able to fail over to a multiplexed copy that contains all of the same pointers to the parts of the database and be able to raise the database as normal. Same thing with online redo log files. If you're not maintaining redundant copies of those redo files and you lose one, then there goes your capability of being able to roll forward or play back transactions that were stored on that file. This is an important slide for us because it shows us how data is actually stored in your data files. And I've put it in order from the most granular at the top to the broadest at the bottom. The fundamental unit of data storage in Oracle database is what's called the Oracle block. All right? You'll see references to blocks all in the Oracle literature, and we'll be working with it later in the course. Oracle blocks consist consist of one or more operating system blocks. So you also need to understand what that is. An operating system block in Windows is called a cluster. It's the smallest allocation unit for data. Traditionally in NTFS, you have a 4 kilobyte cluster size. That's the smallest, most atomic unit of data storage on a disk, such that if you were to store a 2K file, how much space would it take place on the disk? 4, right? Because the cluster size is 4. Now, it's suggested as a best practice, many Oracle DBAs set their Oracle block size to match the underlying operating system block size. That's best practice. Second best practice would be to do a multiple. Let's say you wanted Oracle blocks a little bit bigger. You might set your Oracle block size at 8, which is a perfect multiple of 4 in an NTFS environment. You always want to use either the same block size or an even multiple, okay? And as I said, the Oracle block, as far as Oracle is concerned, is the fundamental data unit there. An extent in Oracle nomenclature is a collection of Oracle blocks. The default are 1 megabyte chunks. I'm sure it has to do with reducing disk I/O, but when Oracle allocates space to your database objects, let's say for instance you run create table to create a new table in a table space, Oracle isn't going to provision X number of Oracle blocks. No, instead it's going to provide one or more extents, collections of blocks to that new object. Now, each object in a table space, whether it's a table or an index or whatever, is stored in a data object called a segment. A segment is a collection of extents stored in the same table space and are allocated to objects. So if you have a database that consists of 3 tables, and those 3 tables are defined in a single data file in a single table space, you can rest assured that each of those tables has been given or is identified as a segment, an initial collection of extents. So each object will get an initial extent and then incrementally given more extents as data needs dictate. Finally, as you know, table spaces represent the logical storage unit of the database. Table space can have more than one data file, but only one data file can be associated with any one table space, if that makes sense. Let's complete this very involved nugget with a brief consideration of the data dictionary. The data dictionary in Oracle Database is a read-only collection of base tables and views that describe the database. In other words, we refer to the data dictionary as a database's metadata, and metadata in turn refers to data that describes data. How's that for you? Now, you access the data dictionary in a few different ways. You can always access it through Oracle Enterprise Manager if you want to. However, if you're in an SQL editor environment, and also for your exam success, it's important that you understand how to get to the major data dictionary views. Now, you'll recall, I hope, that a base table is the fundamental storage structure in a database as far as a logical storage structure. A view, by contrast, is simply stored SQL code. Unless it's a materialized view, you're not duplicating any data rows. The view is meant as a virtual table, where the view can take information from one or more related tables, bring them together. It can suppress some columns, show others. You can create calculated field columns. You can really customize, in short, data that comes back from tables. Oracle has done a good job of giving us a lot, and I mean a lot, of data dictionary views that can give us metadata on any aspect we need regarding the database and its objects. Now, those views are categorized in 3 categories depending upon their prefix. You have user underscore views, all underscore views, and DBA underscore views. Now, these are security trimmed. In other words, a user's user views are going to be different depending upon what the user owns. In other words, a user can query user views to gather metadata about their own stuff, their own database objects that they've created themselves. By contrast, the all underscore views give everything that user does, in other words, everything a particular user has created, but also gives you metadata that's accessible to the current user. Anything in the database, any data object to which the currently logged on user has access, has read access to, you can get to to it using an all view. Now, we DBAs tend to go right to the heart of the matter and access the DBA views. You have to be a DBA to have high-level privilege to access these. These allow metadata for every object in the entire database, including querying the data dictionary data itself. You'll see down in the bottom just a small recipe of SQL code. What this is going to do is grab every view from the data dictionary. The data dictionary is aliased as dictionary here. The spool command is used in Oracle to write out the results of a query to a file instead of the standard out, which, as you know, is the computer screen. We can turn on spooling with spool on. We specify the destination file name, the full path to that destination file name. We run our query, and then when we're finished, we can turn off spooling. It works really well, and this is definitely a tool you should keep in your tool belts. In this final demo, we'll briefly examine the physical structures of the Oracle database. You can get a lot of good information here from Oracle Enterprise Manager. From the Enterprise Manager homepage, we will navigate again to the Server tab. A lot of the DBA stuff, by the way, is located on either the Server or the Schema tab. These are going to be your most popular areas to go within Enterprise Manager. And on a Microsoft-centric note, I've always found this interface to be somewhat redolent of the Microsoft Office SharePoint Server 2007 environment, where you, in central administration, are just presented with all of these links. It's kind of a blistering collection of links when you first see it. It's a little bit intimidating. Anyway, instead of database configuration, where we were earlier to look at memory, let's go to storage, and you see now each of your major storage objects: control files, table spaces, data files, and redo log groups. Let's start with control files. Tells us, first of all, where your mirror images are. You have to have at least 2 copies of your control file to bring a database up and running. And mine are valid, but you see the problem is the directory path for these control files is in the same dadgum folder. We're going to want to change this, definitely, and multiplex our control file, put our control file copies on a separate physical disk, because if the C drive fails here, or if we lose our ORCL folder under Aura Data, we are hosed, okay? Now you notice that this gives us 3 tabs for the control file. The General tab just gives you a list of their mirror images. The Advanced tab gives you a little bit more detailed information, some metadata. You'll notice that you can specify an auto backup regime of the control file. You just click to enable it if you want to. You have to specify a location, a backup location where you want that file to be. I'm not going to configure that right now, so I'll step back. And then the record section tells us what the contents of the control file are. Now, another way to look at the control file contents is to back up that control file to trace. And what that does is creates a plain text backup and places it in this path. Let me jump to that path really quickly. This is the backup dump dest parameter, by the way, that Oracle is pulling from. Let's find the trace folder, and let's do an inverse sort by date modified, and there is our plain text representation of the control file, alert_sid, the name of your database, .log. And the reason why we have to back up to trace is because the control file is a binary file, so we can't read it with a plain text editor by default. Gives us system parameters with non-default values, gives us licensing information, what kind of auditing we have enabled, it gives checkpoint information, it gives process startup information, just all of your metadata that's crucial to raising your database. So that's the control file. Let's come back to storage under server, take a look at table spaces. Of course, we can manage all this from SQL Plus as well. When you bring up a database based on a template, Oracle gives you a bunch of table spaces. I loaded the sample schemas, that's why there's an example table space. System and sysaux are internal to Oracle. They're absolutely crucial, somewhat akin to the master database in SQL Server. Temp is used for, well, temporary operations. Undo TBS1 is your undo table space that's used for storing changed data blocks in the case of data rollbacks. You can easily roll back to previous values. We'll talk a lot about that later. And then your user schemas are stored by default in the user's table space. Now you notice you can edit, view, delete. You can add a data file. You can copy characteristics of table spaces to build a table space off of properties on an existing one. You can do all of your table space management from Enterprise Manager. here. It's very convenient. Data files are obviously related to table spaces. When you bring up a new data file, you'll have to specify which table space that data file is located in. And you'll notice that by default in this general template I used when we brought this database online, we have one DBF file per table space. There are many reasons why you'd want to add additional data files, but this is just our default loadout. And then finally, our redo log groups. You see that, again, based on the template that the DBCA used, we have 3 redo log file groups. A group is a collection of one or more members. You have to have at least 2 redo log groups, just like you have to have at least 2 control files to bring a database up. Now, yes, indeed, you'll want to have members of each group located on different disks, such that the failure of one disk would preserve a redo log member on another disk. So the idea with the groups is that you're giving Oracle a lot of disk space to work with in terms of storing that redo log information, and once the first group's member is filled up, a log switch occurs, and then the second group becomes active. In this case, at this point in time, it looks like our redo log group 3 is current, and redo log information, or redo information I should say, is being written to this member here. And again, you can edit, view, delete, you can clear log files, you can force checkpoints, you can look for sizing advice, you can force a log switch. In fact, let me do that right now. Switch log file, go, and now you'll see that log group 1 is our current group. It's all about data protection, everybody. It's all about trying to create as much redundancy as possible such that the failure of a file, the failure of a disk will not bring down your database. Final thing I want to quickly show you is our initialization parameters. Those are actually stored on the server page under data configuration. If we go to initialization parameters, we can query the list just by running a search. For instance, if we want to look at our memory target value, we can just put that in there and it gives us the name of the value, and note that we can not only change the value here, but we can optionally document it if we've made a change, and then you can specify, of course, a SQL in some cases, and then whether the change is going to be to memory, which is the default, or if we save to file, that will make our change permanent by recording that new value in the server parameter file. Exploring the Oracle Database Architecture review. In this nugget, we covered a lot of ground for sure, and we have a lot more ground to cover in the future, that's for sure. We began with database basics. Right now, you should understand the difference between a flat file and a relational database. You should be able to describe what an object relational database, like Oracle itself, is. You also by now should understand both the theory as well as some practical application of the 3 structure systems in Oracle Database 11g. The memory structures, should understand PGA and SGA and how to size those, process structures, the database writer, the log writer, and the other major background processes that work on behalf of users and the server itself to keep the database in good order. And finally, the storage structures, both the logical and physical storage structures. Things like table spaces, data files, control files, and online redo log files. If you're feeling a little beat up and a little overwhelmed, please take heart. We're going to continue to work with this terminology throughout the remainder of the course. It always is pretty much like a big flood of information when you get started, but once you start getting your sea legs and start getting grounded in this stuff, before you know it, you'll be speaking and acting like a real Oracle DBA. I hope that this has been informative for you, and I'd like to thank you for viewing.